Math Stars. Today we will be working on this lesson 10 problem set. Super fun, super amazing because it is pretty much the exact same thing we did yesterday with composing large fraction units and expressing the equivalent fraction in a number sentence using division. So let's do some problems together and then you guys should be all good to go. And once again, you can, in these problems, you can ignore this question mark. I think it just got a little funky with all the transferring these papers have to go through, but you could totally just ignore all of these question marks. Okay, so let's start off with 1A. It asks us to compose the shaded fraction into larger fractional units and to express the equivalent fraction in a number sentence using division. So I'm going to walk you through this problem that they did with you. So first things first, they counted the total number of pieces in this chocolate bar, in this area model. And the total number of pieces are 1, 2, 3, 4, 5, 6. So our denominator, our number on the bottom, is 6. How many of those pieces were shaded in? Well, 1, 2, 3, 4 were shaded in. And then they went ahead, okay, how can we show an equivalent fraction here? How can we show an equal fraction here? By using division and by showcasing that on this area model. Well, they went ahead and looked at, okay, how many pieces were created by this horizontal line that runs from left to right? How many pieces were created? Well, 2 pieces were created from each vertical piece. Okay, so they went ahead and divided the numerator and the denominator by 2. Just to be sure of my division skills, I'm just going to go ahead and list my multiples just to be sure. So listing my multiples, and by skip counting, I know that 2, 4, 6. 4 divided by 2, that's 1, 2. 6 divided by 2, that's 1, 2, 3. So it is safe to say that 4 over 6, or 4 sixes, is the same thing, or it's equivalent to 2/3. And we can also showcase that in this area model. How do we do that? It essentially just is 1, 2, 3 pieces, and 2 of those pieces are shaded in. We are ignoring that horizontal line. 2 out of the 3 are shaded in. Okay, go ahead and do B, C, and D on your own for number 1, and 2, A, and B. If you need more guidance, please feel free to go back to yesterday's video, which is the lesson 9 problem set. I'm going to run through a quick example for number 3A, which asks us to draw an area model to represent each number sentence below. Okay, easy peasy stuff over here. We're just working backwards. So now they're giving us a number sentence and we have to draw the area model and prove that this is true. So let's go ahead and do that. I am going to go ahead and first make sure that I have 10 pieces. So I'm going to draw my chocolate bar, draw my area model, and make sure I have 10 pieces. And you might be wondering, okay, so how am I supposed to figure out how many vertical lines there are, how many horizontal lines there are? Well, I'm going to show you a trick. Is I'm going to look at the equivalent fraction, which is 2 over 5. And since 5 is the denominator for my equivalent fraction, I know that I'm going to have 5 pieces that run from up and down. So I'm going to have 5 pieces that run from up to down, 1, 2, 3, 4, 5. But I can't go from there because I have 10 pieces total. So I'm going to head and draw just one horizontal line from left to right. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. And since 4 is my numerator, I know that 4 of those pieces are shaded in. 1, 1, 2, 3, and 4. Okay. So this is my area model. And if we are working with division, we could say that 4/10 or 4 over 2, or I'm sorry, 4 over 10, divided by 2, divide the numerator, divide the denominator by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. We get that 4/10 is equal to 2/5. So go ahead and try 3B on your own. Just also want to recognize really quickly that, so they divided by 2, and why did they divide by 2? So they divided by 2 because how many pieces did this horizontal line create for each vertical piece? Well, if we're just looking, let's just look at this piece really quickly. This horizontal line created 2 pieces from this vertical piece, which is why they divided by 2. So think up here. Think about B then. How many horizontal pieces should there be if we're dividing by 3? Okay. If there's 2 pieces, if we're dividing by 2, how many vertical pieces should there be if we're dividing, or horizontal pieces should there be if we're dividing by 3?